Problem solving is an important aspect of most jobs. And how well people solve problems often determines their effectiveness in their job. Effective problem solving often involves careful consideration of many factors to come up with the best solution. We solve problems of one kind or another almost every day, not only at work, but in all parts of our daily lives. So that we can deal with problems in a general way, we need to define the term problem in a way that can apply to a wide range of situations. With this in mind, the term problem can be defined as a difference between actual conditions and desired conditions. For example, in an industrial plant, there may be a difference between how much fluid a particular pump is moving and how much the pump should be moving. In this case, the actual condition is the amount of fluid moving through the pump, and the desired condition is the amount of fluid that should be moving through the pump. Another way of looking at problems is based on whether the solution is within your area of influence or control. Based on this idea, we can divide problems into three types. First, there are problems that exist within your control. You generally can solve these problems directly. Second, there are problems that are partially within your control. You may be able to solve these problems if you have cooperation from outside of your area of control. Third, there are problems that are out of your control altogether. Any problem you consider should be evaluated to see if the solution is within your or your group's area of influence or control. You can do this by asking a series of questions. Does the problem occur most often in the area where you or your group work? Does your group have access to the information and people needed to understand the problem and potential solutions? Can you easily reach and influence decision makers to get the resources you need? Does the situation deserve the effort right now compared with other priorities? Are the people involved committed to making a change? Yes answers to all of the questions indicates that the problem should be readily solvable. A no answer to any of the questions suggests that the problem may not be solvable within your group alone, or it may not be advisable to address the problem at this time. It is unproductive to waste time and energy on problems you can't solve. But when you encounter a problem that is out of your control, you should consider whether there is any action you should take, such as notifying or warning someone of the problem. Also, you might be able to offer suggestions even if you don't have the authority to solve the problem directly. If a problem can be defined as a difference between actual conditions and desired conditions, problem solving can be defined as the process of changing actual conditions to bring them closer to desired conditions. A simple example might be adjusting the control on a heating system to bring the actual temperature closer to the desired temperature. More complex situations require a systematic process that may involve other people, departments, or organizations, and consideration of several possible solutions. There are a few general principles to keep in mind when you're dealing with a problem. The first, and perhaps the most critical principle in problem solving, is that the problem must be recognized and acknowledged. Denying the problem or ignoring it generally makes situations worse. Working around the problem may keep things going for the short term, but most of the time, a Band-Aid fix that doesn't address the real cause will make matters worse in the long run. Now, once the problem is recognized, accurate and complete information is required to understand the problem and determine the causes. Determining the causes of a problem usually points the way to the solution, but it's extremely important not to get involved in pointing fingers or assigning blame. Also, most problems have more than one cause, so a good solution must address all of the factors that contribute to the problem. Involving other people in the process can provide more and better information, and often will offer a range of approaches to solving the problem. It is also necessary that those who implement the solution be committed to it. We'll organize the problem-solving process into 5 main steps. The first is to define the problem and the goal for solution. For instance, if the problem is increased costs associated with the return of defective product, the goal might be to reduce the costs associated with the return of defective product. The second step is to gather information. We can look at the manufacturing process, the testing and quality control process, and perhaps even the design of the product. Once all of the information has been examined, the problem might be redefined. For example, it might be discovered that not enough product is tested before being shipped, and the goal might be redefined to reduce the costs by reducing the amount of defective product being shipped. The third step is to generate alternatives. In this case, some alternatives might be to revise the quality control procedures, hire additional personnel to test the product, or provide additional training for existing personnel. The fourth step is to make a decision as to which of the alternatives is best. Evaluating the alternatives will require further analysis, including how well each will meet the stated goal, and looking at the costs and benefits of each alternative. The fifth and final step is to implement the solution. It's important to develop a good plan of action and evaluate the effectiveness of the solution. The first part of the problem-solving process involves defining the problem and defining the goal for solution. We've defined a problem in general as a difference between the actual conditions and the desired conditions. So one way to define a specific problem is by defining the actual conditions in relation to the desired conditions. In other words, we must define what is happening that should not be happening, or what is not happening that should be happening. The goal is then defined by the desired conditions. Consider this situation.
What do we got?
It's section 2 again.
Control to section 2.
Go ahead, Control.
Yeah, Pete, I got an alarm on section 2 again. Can you check it out?
Okay, I'll get on it.
And this is Pete. They fixed this system just last week. Maybe it's just a bad transmitter.
Let's see what happens.
No, Pete, look, I think we've got a real problem. I'm going to shut the system down.
Anne has accepted that there is a problem. That is the first step in solving it. But Anne cannot solve the problem by herself, so other people must be involved in the process. Also, this incident is only part of a larger problem.
Well, thank you all for coming this morning. And you did the right thing by shutting the system down when you did before any major damage was done. And you were able to get the system back up quickly. But that's the third time this month that system has gone down, and it's causing us problems in other areas. What can you tell us about what's happening with that system?
This is a critical point. Anne is about to begin the process of defining the problem.
Well, we're logging much more downtime on that system than we did a year ago. Now, I know maintenance has made a number of repairs lately, but it seems that just when you think the thing is fixed, something else goes. I really don't know what to tell you without more information, but I do know we need to do something.
Anne has clearly acknowledged that there is a problem, and that was an important step. She has also committed herself to the need to solve the problem. But Anne knows that to understand the problem and find a solution, more information is needed, and she was careful not to blame any specific person or group.
Okay, and I think we all agree that something needs to be done. John, what does it look like from your point of view?
Well, we have been in the system a lot lately. I think the problem is that they just run the thing too hard and never give us a chance to fix it right.
Oh, that system's been down a lot lately. Should have been time to fix it right.
Easy, Pete.
By trying to assign blame or suggesting a cause, John and Pete are squaring off to deflect blame away from themselves and their departments. This is often a natural reaction, but if it's allowed to continue, it will create conflict and hinder the effort to find the solution to the problem.
Look, guys, I know it's frustrating, but before we start blaming people, we need to look into this some more.
You're right, Ann. But we're all under pressure to keep this system running at full capacity.
Okay. We need more information to solve this. Ideally, we need to try to eliminate all unscheduled downtime. Do you think we can do that?
I would think so.
John?
Yeah, I would think so, but before we commit to that, we're going to need to know what's changed since last year.
All of the key personnel have been heard from. Now it's possible to tentatively define the problem and set a preliminary goal for its solution. Bill summarizes.
Okay, so we all agree that the problem is increased downtime on the system as compared to a year ago, and that our goal is to eliminate all unscheduled downtime. And I think we also agree that if we're going to solve this problem, we need to gather some more information.
Once a problem is defined and a goal decided upon, it is usually necessary to collect more information about the situation so that a good solution can be developed. Also, once the information is collected, it may be necessary to redefine the problem, the goal, or both. In our example, the problem and the goal were defined like this.
Okay, so we all agree that the problem is increased downtime on the system as compared to a year ago, and that our goal is to eliminate all unscheduled downtime. And I think we also agree that if we're going to solve this problem, we need to gather some more information.
There are some general methods that can be used to gather information that can help you understand a problem. First, ask the people who are involved. The people who are directly involved or affected by the problem will often give the best insights into what is happening and why. Second, observe the process. Direct observations can verify what is actually happening. Third, check the records and other documentation. What has happened in the past can provide important details. The process of gathering this information can be summarized with 6 one-word questions. Who? Who is involved with or affected by the problem? What? What is really happening versus what should be happening? When? When does the problem happen? Where? Where does the problem happen? How? How is the problem being handled now? Once these questions are answered, the last question is, why does the problem exist? In general, however, it is not necessary to answer these questions in any particular order. Let's see how they begin this process.
The problem is confined to this system. It seems like every time it goes down, it's something different, so it's difficult to pin down the exact cause. But the end result is almost always a loss of pressure, which requires the system to be shut down.
You know, the plant down south has a similar system. Have you checked with them to see if they're having problems?
Yes, they're not having anything like what we're having. But their system is a lot newer, and they're not running it as hard as we are.
Now, let's see how Ann continues.
Pete, do these problems occur more with any particular people operating the system or in any particular shift?
Nope. The trouble log shows that the breakdowns are totally unpredictable.
Okay. Joe, can you connect any particular technician with the problem?
No. According to my records, each of the major failures this month has followed the work of different people.
I think we can conclude that the problems aren't happening at any particular time or as a result of any individual's actions. Agreed?
Yeah.
Yeah.
Now, 4 of the 6 questions have been answered, but we still don't know why the problem is happening. Perhaps exploring how the problem is being handled now will tell us something.
So, tell me, when the system loses pressure, how is it handled? Pete?
Well, once it's shut down, we have to figure out where the loss of pressure is and solve that. Sometimes it's a valve, sometimes it's some other kind of fitting. One time there was a problem with the pump.
Yeah, we patch it as best we can, but we are always under pressure to get this system back online quickly.
Yeah, I can back that up. We keep getting these memos on how good sales are and that we need to crank out more and more product. So we're always pushing to either maintain or increase production.
You know, I see this thing from both the operations and the maintenance point of view, because I'm usually out there. It used to be that the system was almost never down, except for scheduled maintenance periods. But with the increased demand for the product, we haven't been scheduling those periods as often.
Well, that's true. And this system's got a lot of hours on it. It's beginning to show signs of age. I mean, when we do go in, we're only doing the minimum necessary to get it back online quickly. I would bet you that even now there are components in that system that need replacing, but we're only given time to fix the immediate problem.
I'm sure he's right about that. We spent some time just watching the gauges, and they held pretty steady most of the time. But every once in a while, the pressure would fluctuate. Nothing bad enough to set off an alarm, but an indication that there could be a problem.
You know, it sounds to me like the key to the problem is that there hasn't been enough time for planned preventive maintenance.
Answering the how question, how is the problem being handled now, we see that the cause of the problem has to do with a lack of preventive maintenance, which begins to answer the why question. But is that really the whole story? Problems often have causes that are more complex than our first thought. By asking why, Bill looks deeper into the problem to find out what's really happening.
Why do you think there's a lack of preventive maintenance?
Well, with all the pressure from the front office, I guess we have pushed the equipment too hard.
Yeah, and when we do go in and fix something, we just hope it'll run okay for a while. Without being able to shut the system down for something more than just a quick fix, we're going to continue to have problems.
So this problem is more complex than meets the eye. Based on the information we've gathered, the problem is redefined.
Okay, so another way of defining the problem is that needed maintenance has not been done because of the need to put out more and more product. But we still must find a way to reduce the downtime on the system. And we've already agreed that our goal is to eliminate all unscheduled downtime. So, now does everybody agree with what the problem is and what we need to accomplish? Well, now we need to figure out how to do it.
Once the information has been gathered and the problem and the goal are well defined, the process of finding a solution begins. One commonly used method is called brainstorming. In brainstorming, everyone involved is encouraged to suggest ideas about how to solve the problem. Here's your chance to think creatively. Sometimes a solution is derived from the most outrageous idea that comes out of the session. Every idea is written down, and none of the ideas are rejected at this stage, even those that seem absurd or impossible at the time.
Okay, so who wants to start?
Well, one option would be to do a total overhaul on the system.
Okay, overhaul the system. What else?
Another approach would be to replace the entire system. Of course, the problem with that is it's pretty expensive, and it leaves us...
Hold on, John. We'll record the idea of replacing the entire system, but we won't consider any negatives during the brainstorming process. All right, what other ideas are there?
We might have to ask management to give us the okay for a scheduled shutdown.
That's likely to be an element of several of these suggestions.
So far, we're keeping up with demand, just barely. We might be able to do nothing for now and continue the way we have been for a while. Maybe things will settle down.
Okay. No action for now. What else?
It might be possible to schedule short maintenance periods and go through the system piece by piece.
Brainstorming continues until a specified time limit is reached, or everyone in the group agrees that all of the ideas have been listed. At this point, we have a list of ideas. Before we can choose a solution, it may be necessary to develop more information about the alternatives. Collecting more information about the alternatives is important in the evaluation of the alternatives.
Before we decide on any of these ideas, we need to look at cost and time estimates for each approach. And we also need to be satisfied that whatever solution we agree on can get us to the goal.
I'll talk to the people in maintenance to get the time and cost estimates together.
And Pete and I can take a look at the production schedules and see what the effect would be on production.
Once all of the information is collected, a decision can be considered. Once the problem and the goal are defined and alternative solutions have been identified, the next step is to make a decision. The more complex the problem is, the more complex the process of making a decision will be. In our example, the brainstorming session has generated 4 alternatives: overhaul the system in one step, replace the system, take no action for now, and overhaul the system in a series of short maintenance periods. We'll divide the process of making the decision into 4 main steps. First, determine which solutions will meet the stated goal.
Well, let's go down the list to see which of these alternatives will allow us to reach our goal.
Replacing the system should accomplish the goal once the work is completed.
And I think we'll all agree that a complete overhaul will also get the system into a more reliable condition that will meet our goal.
Either one should get us to a place where we can eliminate all but scheduled downtime for maintenance.
Now, do we all agree that taking no action and continuing as we are would not accomplish our goal?
Yeah, we would be asking for worse trouble down the line.
Okay, we'll cross that one out.
The alternative of overhauling the system step by step should eventually accomplish the goal,
But it would have to be done over a longer period of time.
Second, consider possible problems for each alternative and discuss how those problems would be handled.
Now, what kinds of problems do you see with the 3 remaining possibilities?
Well, the time required to replace the entire system would stop production for too long to do us much good.
If we decide we need to replace the entire system or even shut down long enough for a total overhaul, then we're definitely going to need management's okay for a scheduled shutdown.
Well, the overhaul wouldn't take as long as the replacement, but we'd still need the okay to take the time.
Also, if we plan a full overhaul, we might run into some things we haven't planned for when we get into the system.
Well, how would we deal with that situation?
Depending on what it was. We might have to order additional components or make repairs we hadn't planned on.
Okay, well, how about doing it a little at a time?
We'd have to plan the work carefully to minimize the cost in terms of lost production time. But the total downtime over the period shouldn't be too much more than we're getting now.
And scheduling the downtime would definitely be less disruption to our production.
The third step is to compare the cost of each alternative to the potential benefit, sometimes called a cost-benefit analysis.
We might get some overtime costs if we're going to keep production levels up.
Yeah, but in the long term, it's worth a little overtime if we're going to maintain our production output.
The cost of materials is going to be similar whether we do the overhaul a little at a time or all at once.
Although a completely new system would certainly meet our goal of reliability, the cost of labor and materials would be much higher than the other options.
So replacing the system would cost much more than the other alternatives, and not only in terms of materials and labor, but also in lost production. I think we can cross that one out. Okay, agreed?
So now it's down to whether we want to do the overhaul all at once or a little at a time.
Yes. Now, let's take a closer look at the 2 choices left.
The fourth and final step is to make the decision. The discussion continues evaluating the 2 remaining alternatives, ultimately arriving at the one alternative that offers the best solution.
Well, it seems like we're in agreement here that the way to do the overhaul is in small, scheduled steps.
That'll give us access to the system to do the needed work without losing too much production output.
Well, that seems to be the consensus. Anybody disagree?
Okay, guess we've got work to do.
This decision was not the only possible solution, and it was given here only as an example to illustrate the process. The actual outcome of a situation like this might depend on factors outside the control of this group. Once a decision is made on the best solution to a problem, successful completion of the process depends on developing a good plan of action. There are several elements of a good action plan. First, everyone who is involved in implementing the decision or affected by the decision is informed about the decision and how it will be implemented. Good communication at this stage will help gain the acceptance of the plan on the part of those who must do the work. Second, the actions or tasks required for completion of the plan are specified and scheduled. Careful scheduling will avoid conflicts and other problems down the line. Third, a responsible person is assigned to each action or task. Assignments should be consistent with the capabilities of the individuals. Consider whether or not additional training is required. Fourth, plan for possible problems. Make a list of possible problems. Plan how those problems can be avoided and what to do if the problems occur. All of this information should be documented in writing. Fifth, provide for evaluating the plan and the results. This includes tracking the work in progress and then evaluating the results once the work is completed. In the example we've seen of planning for the overhaul of a large industrial system, the evaluation of the results will be based on whether or not the end result achieved the goal. That is, that unscheduled downtime for the system is eliminated.